Welcome back. We are now at lesson 13C. It's called A Lesson Worth Waiting For. The administration at your community college is concerned about a report that the mean body mass index, the BMI, for United States adults is increasing. Administrators are considering a college health awareness campaign, but first, they want a measure of students' average BMI. Question 1 is a question you should pause, go work on yourself, even read through the objectives, add to some of your flashcards, and then just after the objectives, read through that piece too. And then I'll catch back up with you after that. And then after you're through, come back and we'll talk through question 1 together. So looking at question 1, there are too many students at your college to measure the BMI for everyone. Part A asks us to describe a process that could help our college estimate the average BMI for our student population. And then part B, which would be more appropriate, an observational or an experimental. So in part A, one approach would be that we could randomly select students from our college to measure their BMI. We could then use that average to make an inference about the entire population of the college students. So that lends to answer part B, that we would need to do an observational study. That's what would be appropriate. So looking at our objectives, make sure you have your glossary page or flashcards close, because in this lesson we will understand that in observational studies, representative samples are used to make inferences about populations. That should already be on a flashcard. But this one would be a new flashcard. Simple random sampling can generate those representative samples. Representative samples yield statistics that are very similar to population parameters. Statistics from samples always include sampling error. Larger samples tend to yield statistics with a smaller error. We're also going to begin to be able to identify principles that would generate a representative sample. How are we going to get one of those? And we'll begin to be able to implement a sampling process, the sampling process for generating that representative sample. We use representative samples in observational studies. That needs to go on the card. Oh my, hopefully you can still see the word. I'm not doing a good job at that one. Let's undo. There we go. We use representative samples in observational studies. One way to gather a representative sample is through this thing called a simple random selection. When gathering data through simple random selection, every member of the population has the same chance of being selected. A random sample, new flashcard, is one that is chosen by random selection. A lot of words going on here. Good time to pause and reflect. Continuing to read, it says an observational study will help us to learn about the mean BMI at our college. Because there are too many students at your college to measure each of their BMI values, you decide to identify 20 students and compute a sample average BMI. So let's assume that your college has 540 students. Each of these students has a BMI that is unknown to our college. The following table assigns an ID number to each student from 1 to 540 and gives the respective student's BMI. What we're going to try to do is to replicate a study. We're either sitting in a classroom together or you and I are talking through a recorded video together. So we're just going to do the best that we can. In the lesson, there is a generated list of 540 students. Let's get oriented to this list where there's an ID number, like this student is 1, and their BMI is 29.1. If we go over here, the 490th student, that's their ID number, 4900, and their BMI is 29.6 or 29 and 6/10. So while this population of 540 is small in comparison to other populations, it is still way too large for the administration to survey every student. Measuring a student BMI requires a visit to the college's health center, and 500 visits are not possible given time and staff constraints. So let's do our own study. Question number 2, one way to randomly select members from this population is to use a random number generator. Many calculators and computer programs have random number generators. And these are some good thoughts to add to the cards or glossary that you're already working on. So part A says randomly select 20 student ID numbers. If using a random number table, pick an arbitrary starting point and write that number on the left of the first line of your notebook. From your starting point, move right or left in the table, a lot of directions, recording the ID numbers in the column down your notebook paper. So I have uploaded the list that you see in front of you, and it's just a partial list. It says the table below lists the student ID numbers from 1 to 540 in random order. And remember, for us to have a good study, we have to pick numbers or students randomly. We can't just look around and go, hey, I'm going to pick number 1, I'm going to pick number. You have to verify that what you're doing is random. And so one way that they were just describing on question 2A is to, like if we're using a table like this, pick an arbitrary starting point. So I can close my eyes and I've touched a number. And I'm at number either 100 or 106. I'm at a number 106. So make sure you carry out this experiment to get it in your hands and in your mind that right now I have landed on 106. And part 2A says, write that number down. And so I'm going to pull out a piece of paper, and I'm going to do this not while I'm on the recorder, but it says write that number down and then choose to go either left or right on this table. It doesn't matter. You pick to go one way or the other, and then we're going to record those numbers in a column. And we need to record 20 because then we're going to take this 106 and go look for student ID 106 and write down their BMI. I'm going to go ahead and go to the right. So I'm going to need to write down these numbers, keep on going to the right, and I'm going to need to write down 20. So I am going to write these down, and I may actually type them in an Excel file, and I'll come back in just a second. While you have hit pause, you go ahead and close your eyes and find a starting number, and then start writing down 20 numbers, either going to the left or to the right. I also have an app, and it's called Pretty Random. Let me see if I can get back to the start of it. And when I go to the first, it's Pretty Random by Fox Bytes. And I'm allowed to put in the minimum number is 1. And the maximum number in this case is 540. And then it's kind of fun because I shake my phone and it gives me a number. Like the first number it gave me was 57. So I can write that number down, shake it again, write down number 90. So whatever you're feeling, if you're feeling like drop the pencil and do the one I've got in front of you, or hey, let's go download the app and shake the phone. Either way, you need to do something random that picks 20 numbers. Go write those down in a column. And then we're going to, after we do that, we're going to go grab the BMIs that go with those ID numbers because we're trying to do a random study and eventually tell the administrators if we think that a campaign is needed on this campus or not to help lower BMI numbers. So I followed what I mentioned. I dropped my pen on the 106 and then I went to the right and then wrapped on around to the next line. And I went ahead and put these in an Excel file. So I have 20 randomly generated numbers for the student ID. Now I need to go find the BMI of that particular student. So student 106. So that's not what I needed. Right here. So these pages are in your class lessons, your in-class student pages. And right here, Right here we have student 106 and their BMI is 29 and 5/10. So I'm going to go here. That student is 29 and 5/10. I'm going to do one more. Let's see if we can find student 130. They may not be on this list. They may be on the other list that I've got because I had to split these apart. And I don't have student 130 on here. So I've got to go get my other list and I'm going to put all 20 of these right here and keep going down, going back and forth, finding 130, putting down the BMI, find 180, put down the BMI, etc. And then I'll come back and we'll talk about what to do on part next. Looking at question 2, part B, it asks us to go ahead and locate all 20 IDs in the body mass index table and write the corresponding BMI next to each ID number. I went ahead and did that. I've got it in my Excel file, my random numbers and corresponding BMI. Part C says now compute the mean BMI for your random sample of students. So I did that on Excel where I typed in, as you see up here, equals average and then my starting cell, colon, ending cell. And the number that we're getting is 26 and about 6/10. And in my notes, it says that whatever we get, you and I should not be, we should be greater than 25, but we should be less than 29. So document the average that you calculated from your random list and the BMIs and then that average, and then move on to question 3. It's a good time to hit pause, work on that, and then come back and we'll work on it together. Question 3 starts out by giving us some more vocabulary. We've seen them, so you may already have the flashcard made, that a statistic is a summary value for a sample, not the population, the sample. And one example of a statistic is the sample mean that we just calculated for our BMI sample. A summary value from an entire population is called a parameter. And look for things that go together. Like a statistic starts with S and that goes with the sample. And here a parameter goes with the population. One example of a parameter is a population mean. If you were to measure the BMI of all students and then compute that mean. Part A, consider the BMI for your sample of 20 students and compare those values to the BMI values of the population. Does this mean, does the sample appear to be representative of the population? So as you look over the list of 540 student BMIs, you will probably notice that the mean BMI, that the values are very similar to what you and I calculated in range, distribution, and there are some that are fewer, but what we calculated is very similar to looking through the entire list. Part B, if you believe your sample is representative of the population, you can use the mean that we just calculated to make a statistical inference about the mean for the entire population because we did it randomly. We then calculated, we did a sample, and if it's looking pretty good here, we can infer information about the population. So write an inference statement about the population. Something you could have written is like the mean BMI for the entire student population at our college is approximately, and I believe mine turned out to be about 25.6. Yeah, about 25.6. And you'd fill in the blank for whatever yours turned out to be. Part C keeps going with a little bit more information. A person with a BMI greater than or equal to 25 is often considered overweight. Does the evidence you gathered, my sample was 25 and 6/10 for the average BMI of my sample, does the evidence that I gathered, this, lead me to conclude that the college administration should implement a health awareness campaign? You know, write what you think based on the sample mean that you got. mine is greater than 25, so I could tell them that since the mean is greater than 25, it would be reasonable to launch an awareness campaign. But then let's continue on to question 4. The mean BMI for the population of all 500 college students is 540. So now, did the statistic computed from your sample come close to this value? Again, you and I are just trying to replicate a study. We're trying to practice doing random. We're trying to practice sample size and average. In this case, they know the entire mean. And in this case, we didn't actually have students go to a medical facility. We're just trying to replicate a study the best that we can. So we happen to know that the mean for the entire population is 27. Whoa, did the statistic computed from my sample come close? Well, mine was 25 and 6/10, and that's close, but, and write in the blank here, fill in the blank if yours was close or not. Part B, here's a brand new word for us. A new word is an absolute error. An absolute error in a statistic is equal to, and here's a bunch to write down, the absolute value of the difference between the statistic and the corresponding parameter. The difference between the statistic and the corresponding parameter. Remember, the S is sample and P is population. And in this case, it's the population mean. What is the absolute error in the mean computed from the random sample of size 20? In my case, I was 25 and 6/10 minus the parameter is 27. So writing down that the absolute value is going to be equal to the absolute error is going to be equal to the absolute value of the difference between the statistic and the parameter. And when I subtract these, I get 1 4/10, but the absolute value is how far this is from 0, and how far it is from 0 is 1 4/10 away. You write down, calculate and write down your absolute error for your sample mean. Part C, what is the cause of this error? And the cause, a part of the cause is we didn't survey all the students. You and I only surveyed 20 students, and so we're not going to be exactly 27. It could happen, but most likely there will be some error. So pulling this back around with some more of our vocabulary, is this research observational or experimental? How do you know? And all that we did in this study is we observed BMI. So this is an observational study since we only recorded student ID numbers and their BMI values. There was no treatment. That's how we know. In the next lesson, we will consider another way of gathering a representative sample that will result in statistics with errors as well. Pretty exciting. We will compare the mean error in that lesson with the mean error that we just computed. This comparison is going to help us to determine whether that method works better than random sampling. So hang on to the data that we just computed and look at your syllabus. If this is it for the week, then you're done. But if it's not it for the week, then keep going on the next video.